Hello guys, this is the second episode about my motorcycle telemetry system. So as you can see, I've started to compress all those sensors into one place, which I will discuss in a second. And there's another interesting part regarding the helmet and the communication of some information through radio directly to the helmet, sort of a HUD display. So let's start with the current integration. So we've got GPS connected to Arduino Mega, which is our central processing unit. We've got distance sensor, TOF, time of flight sensor. We've got our gyroscope, which shows the tilt angles. We've got our MLX temperature sensor, which is showing the temperature without needing to have a contact. So as I mentioned earlier, that would be used for measuring the tire temperature. I've also added a LED display and just configured to work whenever there's an obstacle. It's just for practicing how you can control those LCD or LED display, and that works really nice. You have a control over which LEDs with what color and what intensity are being displayed. I've also printed the dashboard casing that will be using Next-Gen for 4.3 inches display. It's already available on the internet, so I've just used a design. I'm really thankful for someone who produced it and shared it on the web. And of course these LEDs would be included in those tiny areas and programmed to display the relevant information. We've got our long-range TOF sensor as well connected to the whole solution. So that's pretty much it, the whole design. The interesting thing is, of course, we've got the buttons to restart the system. So for example, when we finish our track session, we can stop the recording, and of course we've got our SD card writer attached with the card, so this is where our old telemetry data would be stored. And the interesting thing is I've also added radio communication. So what I was thinking about is, okay, I will have this LCD display and put all that information that I want to have here, and we'll have LEDs that will sort of inform me very quickly about all the vital information during the track session. But then I said, well, maybe that's not enough, because you don't have much time to look at the LCD display. To be honest, on the track I'm practicing, you only have 1 or 2 seconds on a straight where you can look on the dash to see what's going on, check the temperatures and so on. So what I thought was that could be a nice addition or a cool thing to have is, what if we had some sort of display inside our helmet? So initially I thought about transparent LCD display, but that I don't think that would work. There is a lot of vibration. It would be very expensive or time consuming to prepare this. So I said, well, maybe let's just include a LED strip inside the helmet and use the wireless communication. So in here I've used a radio transmitter from the central unit to pass important information, and radio receiver over here. It's connected to Arduino Nano, so very tiny chipset, probably will be attached somewhere here. We'll have to, of course, decrease the size of the battery, but we can use the LiPo modules, so that shouldn't be a problem. And right now it's just a prototype, but I'm really happy with the way it works, because as you can see, I put the LED over there. It's not giving you a direct flash into your eyes. Of course, you can dim those LEDs programmatically, but in here they're actually flashing towards the back of the screen, and there's a very nice tiny reflection produced, which works, at least for now. When I was testing it, it doesn't distract you during the operation, but you can see that there's something flashing. So using this, probably I would have just 3 areas where I would blink diodes whenever something important happens, such as I had the best lap time, the temperature of the tires is dropping, maybe someone's behind me, or I've exceeded the G-force during the braking, which means that was the hardest braking I had during my session. So these things will be communicated over there, and that could be the best way without forcing me to look even at the dash, at the LEDs on the dash. So this is where I'm at the moment. One important thing that might be useful for you guys trying to build similar thing is the speed of processing. So we will have all those sensors connected, and I've already noticed that the main speed that limits how fast we can produce the data logs is our GPS, and the GPS is set to trigger responses every 100 milliseconds, so 10 readouts per second. And that should be okay, but when I've checked how fast actually we're looping and dumping data, it was less than that. It was like 2 or 3 times per second. And what I found out is that LCD display that I'm using right now for debugging is taking a lot of CPU time. It's producing quite a lot of latency, and other sensors add up to that latency as well. So there will be more of those sensors added, and I'm a little bit worried that this might not work, especially that Arduino Mega is not the fastest chip. And the thing that I was considering now was to replace that one Arduino with ESP32 chipset. You can have a look and compare in size how much smaller that is. Of course, I would have to squeeze all the wiring over here, so we will see if that works. Although it's got I2C connection bus where you can connect multiple sensors through it, so I'm hoping that would work. But that chip is 10 times faster, it's got more memory, so this should resolve the latency issues. And the other thing is it already has a Wi-Fi connection, so whenever I collect all the data on my SD card, after the session I could just introduce a button through which I could push it out to the cloud. Of course, setting up the access point through my phone, so that would be very convenient. I wouldn't even have to move the SD card out. I will have a separate episode what I would do with that data, but of course I will use it to learn how I improved, how quickly am I improving, what was the area where I improved. But that's a different story for a different session. So Wi-Fi for uploading the metrics, telemetry data into the cloud, but also rather than having the radio communication, this chipset already has a Bluetooth. So potentially I could use a Bluetooth and integrate that module with Arduino Nano on my helmet, and then have a Bluetooth communication transmitting all those signals to the helmet, as well as use the Bluetooth to control and parameterize my central unit through the phone. So for example, if I wanted to change some of the thresholds for example, the tire temperature above which I should have a red light, I could do that via my phone. So those are my current ideas or issues that I plan to resolve. I should receive a next-gen display very soon, so I'll try to introduce it, include it, and remove that LCD display and see how faster would the data processing and data dumping on SD card look like then. Until that, of course, I'll be very happy to see your comments under the video, and see you later. Until the next time, see you guys.